It's going to talk about pseudo-sums, contingent claims, and a generalized memoryless property. Pasquale, all yours.
Thank you very much. First of all, I want to thank the organizers for this conference. Now, as you can see there, you see Peter. I'm standing there, always smiling, as I always smile in pictures. That was a trip that we had during one of the first boot camps here at NYU. Boot camps are an idea of Peter to essentially welcome the new students in the master of financial engineering. And that was, I think, we were on the boat traveling around on the Hudson River. And as you can see, he was always smiling and always open to speak with students, to interact with students. And actually, I met Peter just before, for the first time, just before he started being the chair here. I was visiting the department to work with Nassim, with Taleb, and I met Peter, and we started discussing about something that fascinates me a lot, but most people consider useless. And that was surprising that he was so interested in something that, I mean, that was actually the first time for me to find someone that would consider interested in something that other people consider useless, that is to say distribution theory, how you can connect all the plethora of distributions you have and how you can change from one distribution to the other by changing one parameter, adding one parameter, removing one parameter, exponentiating, taking the logarithm, whatever you want. And it was very nice. And I think that I can also cite what Julian said, that essentially at that time, I can think that since it was one of my passions, I knew a little bit more connections than Peter. But in a matter of months, since we were discussing, I mean, obviously Peter was much better than me. So at a certain point, I can only say that I learned a lot from Peter. As Claudio, we had weekly meetings, mainly on Zoom, Skype, all the other things, even before the pandemic. And we have been talking about several things for a lot of time. And just recently, we arrived to write some works together, putting together all the discussions that we had over the years. But it was funny because we had these very absurd emails exchanges in which we were writing LaTeX in the email and then reading the other things. And the astonishing thing is that Peter was always able to find typos. So in the matter of 3 minutes, here it is half an hour, but I mean, is there a typo? That's very nice, but is there a typo there? And then obviously there was a typo or something like that. So in that case, for example, I was forgetting some brackets. And that was astonishing. So I could only learn from Peter. There was only one thing for which Peter, we were always discussing during the breaks, and that I can only consider the only situation in which I could, let's say, return the favor of all the things that he told me, and was exchanging tips about restaurants. In that case, I was able to give him tips about New York restaurants, and he would go there with his family, with his wife. And that was extremely nice. So Peter was a foodie, so we were going together. And every time I remember, every summer, we were going to a different pizzeria, and it was like, do you think this is good pizza? And obviously, since I'm overcritical and I'm Italian, I would say, no, this is not Italian pizza. But it's part of the joke. Okay, so what I want to speak about very briefly is essentially a paper that we just finished before the last conversation I had with Peter was on January the 22nd. Just when we finished the paper, we had on January the 29th the idea of going through the final version of the paper, and it did not show up on Zoom. And the day after, you wrote me an email apologizing for that. And I was, okay, what's the point? You are the chair of FRE at Tandon. I understand if you're busy, it's not a problem. He says, no, I don't feel well. I don't feel well. I feel a little bit dizzy. And then that was the last time I had the chance to interact with Peter, unfortunately. So everything starts from one idea that we have been discussing together for a long time. And it's essentially that. What if instead of saying that 1 + 1 is equal to 2, we say that 1 + 1 is equal to 1? Now, obviously, I'm cheating in the sense that this is not what we mean. We want to say that 1 + 1 is equal to 1. What is that? What you see there is what is called a pseudo-sum. So it's, if you want, in lay words, is a redefinition of a sum, so that we can say that if I take 1 + 1 in this new definition of a sum, the result is a 1. And apparently, from the works of Grossman and Katz, the works of Papp, so all the field that goes under the name of pseudo-analysis, you can do that. So, for example, in the case 1 + 1 equal to 1, I should say O+, but it's very annoying. So when I say plus, obviously, I mean the O+. How can we do that? We redefine the summation in that form. So for example, I say that x + y is the exponential of the logarithm of x plus the logarithm of y. And obviously in that simple case, it just reduces to the product. So essentially I'm transforming the addition into the multiplication. So if you want, I'm generating a new arithmetic. I can do the same with multiplication. I can do that with the subtraction. I can do that with the division. Obviously, every time I have to be careful about different things. And then if I do that, 1 + 1 is equal to 1. Now, in more general terms, what we can do is that we can find the recipes to define this type of operations. So we can take a subset of the extended real line, and we can essentially take a function g that maps from R to S, which is our subset, or I could do that also with the inverse of g if I want to go from S to R, which is strictly monotonic. And then I can define the operation in terms of this function g that it's called g because it's also known as the generator. Now, choosing different g's, I can get a lot of nice results. Now, this is nice because, as I will try to convince you, it has nice applications also in finance, but it's also a very nice way of moving from one distribution to the other. So essentially to create new distributions in a very natural way. This is what we call the pseudo-sum. Now, in reality, we can play with a little bit more sophisticated object, which is a monoid, in which we have this binary operation that we require most of the times. It's not strictly necessary, but most of the time to be associative, and with an identity element, that is to say the element such that if I add it in the sum does not change the first summand. And you can easily prove that it's just a transformation of 0, which is the identity element for the standard sum. Okay, if I take 1 + 0, it is 1. Now, if this is the setting that allows for more results. In reality, we can also drop the identity and then play with what is called unital magma. But this is that goes beyond what we can do now. So just to show you that, okay, just to simplify extra condition that we will need, let's consider that our x and y that we want to sum are just non-negative quantities. And then you see that if I define g to be the exponential function, that is exactly the example I was showing you. So it's 1 + 1 equal to 1. But I can also take a power function, so x to the power of p, where p is non-negative. And then essentially you see that I can define an object that resembles a lot an LP norm. Obviously, this is not true when I consider P between 0 and 1, but for P larger than 1, this is actually the Pth norm. And an interesting situation here is also what happens, and that I think was the thing that was the most fascinating, one of the most fascinating things for Peter in this setting, is that if I take P to go to plus infinity, then essentially that operation becomes just the maximum between X and Y that resembles something that we all know. And then you can also have very interesting things because you say, okay, let's choose G to be equal to this stuff. And you say, okay, but why should you be so mad as to choose that? What's the stuff? Why do you take that stuff? Well, that stuff is the soft plus function that she used in machine learning. So these type of transformations are actually quite important and quite useful in machine learning and information theory. And by the way, since I like distributions, this is just the first order integral distribution function of a logistic. Okay, so everything comes from these distributions. Okay, now, little digression. You know from statistics 101 that a continuous random variable X, that we call X, has the so-called memoryless property if it satisfies these conditions. So if I take the probability of X to be larger than the sum of an X1, X2, given that X is already above X1, if I know that this conditional probability reduces just to this is what I call the memoryless property. And if I consider continuous distribution, the only continuous distribution that satisfies that, you know that is the exponential. It's a characterization. So the characterization of one of the many characterizations of the exponential is that one. Like, for example, one characterization of the Pareto is the independence of the ratio of the increments. So there are many ways in which you can characterize distributions. The same thing applies in the discrete case to the geometric. So these are useful things. Now, the idea we had with Peter was to say, okay, but then what happens if instead of this, I say this? So I substitute the sum with the O sum, given a generator. We call this the generalized memoryless property. Now, it turned out that this thing has been already studied several times in the literature. For specific distribution like the Weibull, it's actually a known characterization that goes back to the results of Wold, that Wold. To my big surprise, I also quite recently discovered that my PhD mentor, one of my PhD mentors, published a paper in the 70s on these kind of things. And they gave this intuition about the possibility of defining something like that. Then our definition, the one that we give with Peter, is slightly different, but there is quite some connection. And they proposed in that paper together, it's Mulier e Scarsini, 1973, they proposed essentially with the same idea to move to the multivariate framework of copulas, given a generalization in terms of the exponential, a generalization of the Marshall-Olkin copula. Okay, now, why do you care? Why do you care about these kind of things? There are different reasons. The first one is that essentially it's a very elegant way to rewrite a lot of results in a couple of sentences, really. So a couple of equations, you can rewrite a lot of nice results. For example, the central limit theorem can be written very elegantly using pseudo-sums. And it's quite trivial once you introduce pseudo-sums to see, for example, the log normal CLT when you move to the multiplication, because it's just changing from the addition to the multiplication with the pseudo-sum. You can get new insights in different fields. It's very flexible as an approach, but most of all, it has fascinating financial interpretations. And that obviously was really the daily bread of Peter. So for Peter, it was really like, okay, this is that, this is that. And I was just, okay, trust you. So let's consider an example. I take G to be the power function, so X to the power P. I take it as before to simplify X to be non-negative and P to be larger than 0, so non-negative as well. Now, the pseudo-sum is now this sort of P norm, again, for P between smaller than 1. This is not, but allow me to make this oversimplification. So it's a P norm, and this is a very well-known result. It's a characterization that actually the distribution that in this setting as the generalized memoryless property is the Bible. And this is the CDF of a Bible. This is a known characterization. Actually, we know that one way of characterizing the Bible given by Wald is essentially this one. He was not using explicitly pseudo-sums, but is essentially the same result. Now, let's shrink a little bit the setting. So let's focus a little bit by saying that instead of considering P to be non-negative, I focus on the situation in which P is between 0 and 1. So obviously, I have that this is no longer a norm. It's an F norm, but it's not a norm because it's not subadditive. So it looks subadditivity, so it's not a norm. But the nice thing is that what we notice with Peter is that essentially that strength thing, so that pseudo-sum here, can be rewritten as the expectation of the maximum between X and a quantity which is y dp, where dp is the same conjugate power diagram that Fabrizio was speaking about this morning, which is a random variable with this CDF. Now, here I put on purpose a typo just to test your attention, but it's too late. So obviously that was my error. This is a P, no, it's not a B. Okay, so the nice thing is that this CPD, so conjugate power diagram, is a random variable that has a unitary expectation. It is essentially positive, so it's a radon-Nikodym derivative. And the nice thing is that essentially you can study then the change of measure and all the other things that connects to other things that together with Andrea, that is here in the audience, Andrea Fontanari, we saw that is essentially you have a Lorentz curve that connects as a distortion measure two different probabilities. The two different probabilities are P and Q and blah, blah, blah. So you can derive results also from there. What is that quantity? So to my astonishment, Peter immediately recognized that quantity as the arbitrage-free value of a zero coupon default-free convertible bond with a face value X, which is obviously non-negative, and a conversion value of Y, which is obviously non-negative. And the quantity dP, which is our also radon-Nikodym derivative, is the gross return of the convertible bonds underlying stock. Now, we could discuss what is a default-free convertible bond, but still, in a theoretical framework in which we don't care too much about reality, this is what you can get. And the fact that you have a distribution like the conjugate power diagram gives you a lot of flexibility also in the behavior of the tails. And then connects also to the passion that Nassim and I share about tails. Not necessarily fat, maybe sub-exponential, maybe long, maybe heavy, but still, because the CPD is not really fat, it's more in the sub-exponential field. Another example, and then I will shut up. If you have questions, I'm very happy, otherwise we can have the reception, which is more interesting than me. If we consider another generator, which is the logated logarithm of x, the negated logarithm of x. So it's minus b log of x. Somehow, and that was funny, somehow for the fun of Peter, came out that the generalized memoryless property is now given to another distribution, which is the Gumbel distribution. And he was very enthusiastic of this result. And this is one of the few, that was one of the few situations in which I said, aha, catch up. Because essentially, if you're a little bit familiar with extreme value theory, you know that a way to connect the Weibull and the Gumbel is known as the log Weibull. And now, if you take these, use the logarithm properties, take your b there is just minus the log of x to the power b. And x to the power b is essentially what we saw before, leads to the Weibull. Then you logate, and you take the log, and then you have a Gumbel. So that's, again, this idea of connecting distributions. So you end up with this horrible pseudo-sum that, by the way, corresponds now to this, where this quantity here is a logistic. It's a standard logistic. So it's essentially your 1 plus e to the power minus x, everything to the power minus 1. And that quantity, also that quantity can have a financial interpretation that is essentially the fact that it's the arbitrage-free value of what this time of a zero coupon, that is a zero coupon defaultable bond with face value x, and whose underlying security is essentially a security that has initial value y, and the quantity bz, that in this specific case is not really a Radon-Nikodym derivative, even if it connects to, you can connect that to a Radon-Nikodym derivative through a transformation, is the change in the value of the operation of the firm that is connected to the security. So you see, that was the, and then we also have other examples. And that was a very fascinating way of connecting different things. Obviously, these kind of things works also very nicely in the standard framework, if you consider Black and Scholes. In that case, you can really rederive in a very elegant way very well-known results. So there is no innovation at all, but it's, I mean, it's a rewriting that has at least according to me, but I can also probably have I can also maybe dare to say, according to Peter, was to give a new vision on very well-known things. But sometimes changing the perspective on something, it's something that helps discovering new things. Okay, that was it. Thank you, and most of all, thank to Peter.
Thank you, Pasquale. I think you definitely got the prize for the best pictures. So any questions for Pasquale?
What time is the reception?
That's a very good question.
the most important one, actually.
I'm curious if it's known when, so, I've seen that result on DAGM and option prices. If it's known when option prices correspond with a pseudo-sum, when a pseudo-sum is a valid option price, is that known?
Yeah, so for example, if you consider European call, a European put is essentially a pseudo-sum in the sense that you can see that as the limit of an LP norm when P goes to infinity. So the idea is that at any time, so that is the payoff, but at any time before maturity, you can express the value in terms of a pseudo-sum in which your P has not yet reached plus infinity. We'll never reach, obviously, plus infinity, but just to give the intuition. But it's not close enough to your plus infinity. So you can do that. And actually, one intuition of Peter, which I don't know if anyone will ever be able to solve, is that this could be the trick also to have analytical forms for American options for the code, for the code, sorry.
All right, I see a number of questions here, all of them from Greg Peltz. Oh, that's a previous talk? Okay. Yeah. I see. Any more questions for Pasquale? So if there are no more questions, I thank you again. I look forward to having drinks with you later. And David, would like announcements.
Don't worry, it'll be quick. The refreshments are nearby and prompt, and they're ready to go. Anyway, I wanted to thank you on behalf of the organizing committee of the conference for us attending, and also the SQA, our co-hosts for the event. It was such an amazing day, really. I mean, amazing breadth and variety of talks, and so impressive the impression that Peter's lives has made on all of us. And it's so great that we can leave here with a sense of doing that and doing that in a way that's together, you know, that's really community oriented, as Peter would have liked it. So special thanks to the speakers to coming today. Some amazing speeches. Special thanks to the scientific committee as well, and for their choices, the selections of this very competitive process of the papers that were selected. They're kind of the quiet contributors here today, but they've actually made for a very successful conference. Okay, so the final announcement is that on Thursday night, we weren't able to get Bruno Dupier connected for the memorial speech. He has agreed and has completed a recording for us today, and will be played tomorrow morning. This will all be updated on the website in case you want to double check. Don't have to worry about scribbling down notes, but we're going to be playing it here and also online at 8:50 in the morning. In order to accommodate that, we pushed the registration earlier to 8:20. Okay, so you can see that online. You can see it here. Will be the same thing. It's a pre-recorded. Hopefully, if Bruno's connected, then he can answer questions afterward as well. But we wanted to make sure we had the core of some more presentation available to you. We'll have a short break after that for maybe 20 minutes, and then we will join the regularly scheduled Saturday program at 9:45. The first speaker will be the amazing Jim Gatherall, whose skills you've already seen here this afternoon. And so with that, I've covered all my announcements, and you can go find your refreshments on the 4th floor, the same place we had lunch in this building. Thank you.